Next topic is Poisson's rule. Poisson's rule. So, yes students, this Poisson's rules is explained about covalent character in a given compounds. So, generally, no bond is 100% ionic, but it has some percentage of covalent character. That character is explained by Poisson's rule. Poisson's rule. So, first of all, first rule or rules. Okay. So, simple shortcut method lo ki velipodam direct ga. So, for a given cation, so with respect to cation, here covalent character is increases. Covalent character is increases as increasing the anionic size. So here that is what covalent character is directly proportional to size of anion. Indirectly what? Indirectly with respect to cation, what happened? Size of cation. So covalent character is increases by increasing of size of anion and decreases size of cation. So second one is simple condition. Next for a given anion, covalent character is increases by decreasing of cation size. So same conditions for these two conditions. This is the shortcut remember point. Okay, then third one is here covalent character also determined with respect of electronic configuration of cation. So that is what? Electronic configuration of cation. So that condition is cation with 18 electrons, cation with 8 electrons. Remember. So what is it here? Cation, if at all having 18 electrons, then that is what 18 means. You know pseudo inert gas configuration. That cation is favorable for covalent, or that one having more covalent character. Then if at all cation having 8 electrons, then that one is more favorable for that one is having somewhat it having ionic character. So for that I am taking an example. An example is CuCl and NaCl. So based on this condition, you should easily identify the covalent character and ionic character. So in these two compounds, which compound is having cation ionic character? which one is having more covalent nature and less ionic nature. Okay, so once observed in this two, one anion is same only. So here cation is copper, here cation is Na plus. So I am directly writing outer electronic configuration 2 yite and or otherwise it is only easy and 2 yite outer electronic configuration. I am not writing complete electronic configuration. So in this one, how many total electrons? 18 electrons. In this one, how many valency electrons are present? 8 electrons. So here with respect to cation, this CuCl having more covalent in nature, less ionic character, and whereas NaCl is having more ionic nature, less covalent character. So this is about Poison's rules, and this Poison's rules explained generally. Remember, explained about covalent character, that is covalent nature. Okay, so then already you know this point. Here covalent nature is also determined based on electronegativity difference between the two bonded atoms in a given compound. So here suppose first condition is electronegativity difference between the two atoms is less than 1.7, then it is what? Then it is covalent nature. And suppose electronegativity difference between two atoms is greater than 1.7, then it is having a more ionic nature. What happens if at all both bonded atoms electronegativity is equal? So then that is equal to 1. Then that one is having equal to 1.7. So electronegativity difference is equal to 1.7. Then that one is having 50% covalent nature. 50% is covalent nature, 50% ionic nature. So this is very useful to determine the covalent nature and ionic nature of given compounds. And the competitive side is very important. These two concepts. One is polarization power concept, that is polarizing power and polarizability. And the next one is Poison's rules. Okay. The next concept is VBT, valence bond theory. Okay. Valence bond theory. Valence bond theory. VBT, valence bond theory. So before going to discuss about VBT, which scientists are proposed? So here Hitler and London, these two scientists are expressed, are discussed, are explained about valence bond theory. And here valence bond theory, that is what VBT is expressed about shape of the, important point, shape of the molecule that is covalent compound. Covalent compound, and their bond length and bond angle. So this one is explained shape of the molecule, bond length, bond angle, and especially very important condition. This theory is proposed based on quantum mechanics. Mechanism also. Quantum mechanisms. So based on quantum mechanics, VBT, valence bond theory proposed, and also molecular orbital theory also proposed. So we will discuss about molecular orbital theory in the next classes. So next one, this theory is extended to determine the directional nature of covalent bonds by Slater. Okay, Slater and Pauling scientist. So here this theory also useful to determine the directional nature. Directional nature. Okay. So already we know how the covalent bond is formed. Covalent bond is formed by the overlapping of atomic orbitals. By the overlapping of atomic orbitals with unpaired electrons. Unpaired electrons. Here the orbitals involved in the bond formation belongs to two different atoms. Remember, two different atoms, and the electrons present in that orbitals must be opposite sign. Opposite sign. So ఇక్కడ ఏమని చెప్తున్నాం, కోవలెంట్ బాండ్ అనేది మనకు ఫామ్ అవుతుంది అటామిక్ ఆర్బిటాల్స్ ఓవర్లాప్ కావడం వల్ల. ద సేమ్ టైమ్ అటామిక్ ఆర్బిటాల్స్ డిఫరెంట్ ఆటమ్స్ కై ఉండాలి. ద సేమ్ టైమ్ దాంట్లో అన్పేర్డ్ ఎలక్ట్రాన్ ఉండాలి. ఆ అన్పేర్డ్ ఎలక్ట్రాన్ కూడా opposite spin ayi undali. Okay, and that is covalent bond formation already been. And one more one is day 2 bond. So day 2 bond is also formed by the overlapping of atomic orbitals, in which one atomic orbitals having a vacant, another one is having a lone pair of electrons. Okay, that is commonly we know, but here one condition, very important condition, is greater the overlap, stronger the bond formation takes place. So that is the very important. So condition is greater the overlapping, stronger the bond formation takes place. So this is the very important. So here already we know I said atomic orbitals undergoes overlapping. So which type of overlapping is stronger and which one is formed stronger bond? So here that one is PP orbitals. PP atomic orbitals strongly undergoes overlap and they form strong bond and than the PS than the SS. So here this is the overlapping of atomic orbitals follows this order. Okay, so greater the overlapping, stronger the bond formation takes place. Okay, this is the another condition. Here atomic orbitals that is involved in the bond formation we know. So here while two atomic orbitals are coming close to each other, what happens? Attractive forces and repulsive forces are developed. So that one is represented by this. If two atoms A and B, if two atoms are A and B are taken, then in that one nucleus is Na and Nb. That is what nucleus of first atom A, nucleus of B atom. Okay, and that atoms also having electrons. That electrons represented by Ea and Eb. So question is, attractive forces developed between whom and repulsive forces developed between whom. So here attractive forces. Attractive forces between first condition is between nucleus, between the nucleus and electron of same atom. Same atom. That is what Na, Ea and Nb, Eb. So attractive forces developed between these two, and also second one between nucleus of one atom and electron of another atoms. So that is nucleus of A is attracted by the electron of B, and nucleus of B is attracted by the electron of A. So attractive forces is developed between these two, and repulsive forces. So repulsive forces exist between the whom? So repulsive force exists between whom? Electron of another electron and a nucleus of another nucleus. So that is condition directly writing Na and Nb repulsive forces, Ea and Eb repulsive forces. So attractive forces forms compounds. Okay, so now this is somewhat important postulates about VBT. Okay, and next one is sigma bond and pi bond. So how the sigma bond is formed? So sigma bond, simple definition we want, because we are in a short term period. So once observed, the linear atomic overlapping of the linear atomic overlapping of atomic orbitals gives a sigma bond, whereas lateral overlapping of atomic orbitals forms pi bond. Suppose here observed, here I am taking simply one p orbital, this is also one p orbital. Imagine these two are undergoes overlapping in linear manner, linear atomic combination, then it forms now this one is called sigma. This overlapping is represented by sigma overlapping, and this is, suppose these are p orbital, one p orbital, then it is p orbital, sigma p orbital. Similarly, Suppose this one, end and end also. Okay. Suppose pi orbitals. This is what p orbitals. This p orbitals is undergoes sidewise. That is what lateral overlapping. It forms pi bond. This one, this overlapped place forms pi bond. Pi bond. Okay. Now, see, second point is which orbitals forms sigma bonds and which orbitals forms pi bonds. So here that one is any type of atomic orbital forms sigma bonds. So here any type of orbitals forms sigma bond, whereas in this one only p and d orbitals can form pi bond. So here p orbitals, that is what sigma bonds is. Suppose s orbital is overlapping another s orbital, it forms sigma ss, and suppose p orbital is overlapping another p orbital, then it is formed sigma pp bond. And whereas one s orbital, one p orbitals overlapped, s and p orbitals are, that is sigma sp, sigma bond formed between s and p orbital, sigma bond formed between p and p orbital, s and s. So the next one is p pi and p pi d pi bonds, d pi bonds are formed. Okay. So here the condition, remember, pi bond is formed only after formation of sigma bond only. So what is pi bond formed after formation of sigma bond. Remember, this is the very important point. The next point is sigma bonds, stronger bonds than pi bonds. Sigma bonds are stronger bonds than pi bonds. So based on this condition, I am writing one order that is very useful. That is what sigma pp greater than sigma ps greater than sigma ss greater than pi. So this is very important point. Then next one is here. This is what strong strength of the bonds and the reactivity of multiple bonds. Reactivity of multiple bonds. So here triple bonds are more reactive than double bond than single bond. So this is why? Because their energy is less and their energy is more. So sigma bonds strength. This one is what? Strength of bond. Strength of bond. Okay. So here one very important condition. Sigma bond of 1s orbitals is exceptionally stronger. Exceptionally stronger. This, remember, sigma bond is very strong. If at all that one is formed in between the two 1s orbitals, that is very stronger bond. Okay. And here remember point is one sigma bond equal to or one single bond equal to one sigma bond, double bond equal to one sigma, one pi bond. Okay. Then triple bond equal to one sigma, two sigma, one two pi bonds and one sigma bond. So this one and the last point in this concept one is the shape of the molecules is determined with respect to sigma bond, and pi bond is not useful to determine the shape of the molecule. So this is sigma bond and covalent bond. In the next session we will discuss about overlapping, positive overlapping, negative and zero overlapping, and the next theory, whisper theory. Okay, thank you students.